Hi there. Well, welcome to the part 2 of the introduction to the chain rule. And in part 1 we looked at this very hideous looking picture. And I've never claimed to be an artist, have any artistic ability whatsoever, so I apologize for the sloppiness. But hopefully it gets the point across. And what we did here is we asked the question, how does axle 1, how does the change in axle 1, how is that connected to the change in axle 3? And they're clearly connected by this middle axle, axle number 2. And what we discovered in the end was we discovered that as axle 1 changed 6 times, or turned 6 times, that axle number 3 turned 1 time. And what we did to find that was we reasoned this way. We said, well, if axle number 1 and axle number 2, there's a 3-to-1 ratio there. In other words, this guy would have to turn 3 times in order to turn axle 2 1 time. So there's a 3-to-1 ratio there. Similarly, the ratio between 2 and 3, in other words, when this guy turns twice, this guy's only going to turn 1 time. So between axle number 2 and axle number 3, there's a 2-to-1 ratio. Okay, it turned out that if we multiplied these two ratios together, we get our 6-to-1 ratio. Okay, and this relationship was born. Okay, this relationship right here is the chain rule. Okay, and the idea that if we're interested in how y changes with respect to the change in x, we had to go through these other rates of change before we can discover the overall rate of change. Okay, so let's try to abstract this, and I'm going to attempt to make a connection between the above picture and the actual chain rule, what the chain rule actually is. So consider a function y. Maybe y is in terms of u. And maybe u is a function separate of itself. Maybe it's in terms of x. Okay, so really what we have is we have a function inside of a function. And ultimately what we're interested in is how does y change as x changes? What's the change in y with respect to the change in x? Well, before I get to that, well, we know what it is. It's going to be our dy du over du dx. But before I do that, let's think more about this composite. Another visual to hopefully help you understand this process a little bit better. Okay, maybe you've seen this before. I call them function machines. And it turns out we have two functions in this picture. And we have a function g and we have a function f. And our very first function is g. Okay, in other words, x, the independent variable x is going to get plugged into this first function, g. And what comes out? Okay, well, a u will come out of that thing, and then that u will get thrown into our other function that we call f. And what comes out of f? Hopefully you said a y. So here's another illustration to hopefully get you understanding why we do what we do when we perform the chain rule here. If I'm ultimately interested in how this variable changes as this variable changes, we have to go through this other variable. In other words, y is going to change. I first have to be interested in how does y change as u changes. What's the derivative of y with respect to u first? Well, u is going to change with respect to x. Okay, so y changes with respect to u changes with respect to x. Turns out we multiply those two rates of change together, and we get the following. We get dy du multiplied by du dx. Okay, so this right here is one form of your chain rule. Now, what I want to do is I want to give you another form of the chain rule, because I find some people, they like the different forms. Some people don't like the dy's and dx's, although I think it's superior, but that's just my opinion. So let's suppose that we're interested in the derivative then of, with respect to x, always with respect to x. I guess not always with respect to x, but in this example, the derivative of f. this composite function. Now I'm just going to write the composite function. And the composite function is going to be exactly what we did above. We're just writing it a little bit differently right now. Okay, so f of g. Notice it's the same thing as what we did up here. If I took this guy and substituted him right there, I would get f of g. Okay, so now what does the chain rule say? The chain rule says take the derivative of the inside function. Okay, in other words, the derivative of this function that's in here, the derivative I'm sorry, not the derivative of the inside function, the derivative of the outside function, the derivative of y with respect to u. Okay, well, what's the outside function? The outside function is f. So this is going to equal what? This will equal the derivative of f with respect to, well, that shouldn't be a bracket. Well, I guess it could be. It doesn't matter. With respect to g of x. Okay, so this right here is like my dy du. That's the derivative of my outside function. Now, you have to multiply it by the derivative of the inside function. Well, the inside function is this guy right here, and that's just going to be g prime. Okay, or du dx. There it is. Okay, so here's the other form of the chain rule. Okay, so I hope that made sense to you. I hope it was worth your time to at least start thinking about the meaning behind the chain rule. In the next video, what I want to do is go through several examples with you using both forms. We will use this form, and I should say notation, and we will also use this notation right here. So next video, look for lots of examples. See you there.